Hey guys, welcome back to the next video. So these are the different garbage collection policies out there on your IBM JDK 8. And these are some of the very familiar policies which is used. And I'm going to talk about the advantage, disadvantage of each of this policy to the maximum knowledge I have. Okay. So let's go ahead with the first one, opt throughput. Opt throughput focuses on throughput by minimizing the GC overhead. It uses parallel GC approach where multiple threads handles garbage collection to minimize your GC overload and pause of the world stop of the world pause. Sorry. So here the advantage is that you're gonna get high throughput on effective application for larger heap. So if you're planning for a larger heap, this is the one to go for. The disadvantage is that if you have a real larger heap, the GC process will be long for a major collection. For example, if it is collecting somewhere like 2 to 3 GB, you can see application process for 1 or 2 seconds, depends on the size of your GB which is being collected as a garbage. So that may be like a could be an issue. So it is used to, you can use this in case of batch processing system or application where throughput and latency is very important for you. Throughput is important, not latency. I'm sorry. Throughput is very important, but it should be more important than latency. So there would be a little bit of latency in terms of your application post time. So do remember this when you are going for opt throughput. Next one is opt average pause. So opt average pause reduces the average pause time to improve your responsiveness. So this is basically a balanced throughput and balanced GC pause time. So gives you, it doesn't give you like how the throughput policy gives you, but it gives you more of a balanced approach towards your throughput as well as your latency as well as into as in towards your GC pause time. So it is optimized to reduce the average pause duration during collection. The advantage of this one is basically it provides you balanced between latency and throughput. That's one of the advantage, but the disadvantage it's slightly lower throughput compared to your opt throughput. So you're gonna have this throughput won't be like how you configure opt throughput. Now, do remember this use case scenario is that you can use it for web servers, applications, servers which really have this immediate response need to come and immediate response which is required for your application. So in those situations where you're doing an e-commerce website or something like that, and you want to maintain an average pass time and average throughput as well. Now let's talk about the next one, which is GenCon. So this is basically the default garbage collection policy out there for IBM, JVMs. This is a generational garbage collection that separates objects into young generation, old generation, or the tenure generation. This is basically a short-lived objects which are collected in a nursery, where the long-lived objects is promoted to the tenured space. The advantage is basically an effective for application which has like short-lived objects, reduces the cost of collection in the long-lived object because the focus will be on nursery, and it will be easy if you have the segregation of nursery space and tenured space. Okay, so there is a disadvantage there. You may need to tune your heap size and generation ratio for optimal performance. So you need to find the right balance on your survivor space. You need to find the right balance for your young generation and your old generation. So that's the balance you need to find. You need to do a lot of testing and tuning around that. But where it is used for general purpose workloads. So mostly for short-lived and long-lived objects. So the advantage is that you can configure this either for extremely large-scale operation, large living objects, let me correct that, or short-lived objects. So you can either configure for any of them. The next one is about the balanced one. So the balanced ones has the same region, divides the heap into regions to balance allocation and collection. It performs concurrent garbage collection to reduce pause times and manage fragmentations. The advantage is that it reduces memory fragmentation. It is suitable for large heap and also high allocation rates. Now, the disadvantage is like it's slightly higher CPU usage compared to GenCon because of the allocation and fragmentation. So that's one of the disadvantages. Now you can use this for any applications which is larger than 4 GB of memory. It is used for workloads which requires high memory fragmentation like caching or in-memory database. So likewise, if you're using any of those things, you can use this particular balanced one. The next one is like metronome. So this is basically a real-time GC policy that ensures predictable low latency behavior with consistent pause time. So this provides a pause time guarantee saying that this is the guarantee it's going to be for this much of memory and this much of load. And it basically gives you the real-time system generated one. So that's basically ideal for any real-time systems. The disadvantage of this is like it's slightly slower than throughput due to focus on latency, and it is very useful for real-time application requiring predictable low latency, such as gaming, financial system, and control system. So you can use this for in that scenario. The next one is the no GC. So this allocates memory without performing garbage collection. So there will be no garbage collection performed. Short-lived, this basically has advantage that there is no GC overhead for your application. And the disadvantage is like it is limited use, heap exhaustion, out of memory exception can occur. So this use case is like a short-lived or benchmarking where GC is unnecessary. So I don't see a lot of reasons to use no GC because that's gonna restrict your application from, the application may get into out of memory exception because there is nothing to clear those objects off your memory. So yeah, that's another one over here. So to quickly summarize this, what is what. So if we have this multiple number of GCs out there, you can take a screenshot of this and use this as a reference if you are looking for some kind of answering interview questions or configuring any kind of a GC policy for your system. You can basically have this reference for you guys. Now, how do we set the GC policy on your system? So you have an option to set the GC policy. You can put this under your JVM arguments, and basically this one parameter is enough for you to set it out. So here you can say xgc policy colon gencon. Gencon will create this generation one over here, and this is gonna have this information. And you can replace this with balanced, you can replace this with opt average pause. So likewise you have other things you can replace it with. Now there are certain policies which has the young generation or old generation, and there are policies which doesn't have that. Okay, so do remember this. So for example, GenCon and balanced, these are the GCs which has segregation of garbage collection into two layers. Okay, so one is basically your young generation, old generation, and both of them are the only policy which runs partial GC and global GC because you have two generations here to talk about. Now, the partial GC runs stop of the world scavenge operation on a concurrent scavenge, which basically is to reduce your memory consumption on your young generation and enable the movement of objects just surviving to the older generation. And balanced also does the same. And global is basically balance uses in incremental concurrent mark operation, but here on your gen con it's using concurrent mark sweep. So in terms of getting the sweep done. Okay, so other generations like opt throughput, opt average pause does not divide your memory into multiple segments. So this is very important for you guys to remember, because here there's only one garbage collection policy or garbage collection cycle runs, which is your global GC, and both and this op throughput runs with the GC, the global GC with stop of the world mark and sweep operation, the vanilla one. There is no concurrency in this, so that's why the throughput is high here, because it does one time. So remember in the previous video I also talked about it. So it runs once and it will use all threads to perform the garbage collection. Okay, now what this guy does is that's why this guy has good throughput and less response time or responsiveness. But over here this average guy does, what he does is basically he runs a concurrent mark and sweep operation, which means it will give one thread for marking and one thread for sweeping, where this guy will give you our average pass time and average responsiveness, but this guy will give you amazingly fast throughput, but the pauses will be high here, because this guy will be like working on all threads at the same time. On this one over here, metronome, so here in metronome, so this uses only one single memory allocation and it has only one GC cycle, which is your incremental mark and sweep, stop of the word mark and sweep, and basically runs it in a small interruptible steps. Okay, it will basically classify memory into multiple regions by size and class in one generation, and it will be actually running into a smaller interruptible steps so that it is much faster for your application to perform garbage collection. So these are the things which you should understand before you go and enable this, because when you enable some of them, you may not see the scavenge garbage collection. So you may be telling me, oh, scavenge is not happening, because you have to select what policy you have. So based on a policy, you're going to have different GC cycles. All right. Thank you again for watching this video. It was useful for you. If you have any questions, leave it on the question section. I'll be happy to assist you. Thank you again, and see you on the next one.